Alright guys, this is day 3 of AP Physics Review. We got 9 days left until the exam. Let's go. Alright, let's get started. So for this first question, looks like it's talking about vector addition. And as you can see, there's numbers. So that's how you know
you're never seeing this on the AP test, okay?
So I'll give you guys like 10 seconds to do it. It seems, yeah, this might be like the lightest thing. Yeah, if we get this on the AP test.
Yes, we collectively are passing, bro.
Alright, anyway, so basically it's just asking you to add these ones if the direction, if the positive direction is this way. Let's just assume it is that way. We're going to have a 5 plus 10, and then a 10 minus 5. Oh, 10 plus negative 5. You want to be really freaking fancy. But anyway, it's 15, and this one's going to be 5. Which one is it? 15 and 5. See? All right, boom. So this next question says, the table shows the position and velocity of a car on a straight track several moments in time. So basically it's saying, this is going to be the starting point, I guess. At time 1, it's going to start here. Time 2, it's going to go backwards. Here, let me add like a pink thingy. And then time 3 is going to go a little more backwards. And then time 4, it's going to start going forwards. And time 5 is going to go even more forwards. So the car only moved in the positive direction. Well, we just saw that that boy did not move in the positive direction because it literally went backwards. So it can't be this one. Car only moved in the positive. Well, we just said it doesn't, so nah, boy. The car moved first in the positive direction, and then in the negative direction. Did it? Because I swear this is negative. So it has to be D. I'm not even going to read it because, like, dude. Alright, for this next question, it's talking about, it looks pretty confusing because there's a bunch of subscripts, but it's low-key kind of easy. So basically, it's talking about a student moving in the x direction. Okay, that really doesn't matter, but just know that he starts, okay, we're going to have this little boy. He's going to start here. I'm just going to write start. I'm not even using no variables or anything. So then he's going to have a change in position x1. So let's say this is x1. He goes all the way over there, okay? And then it says he starts moving a second time in the opposite direction. So if the first time went right this way, the next time, where does it go? I hope you guys aren't stupid. It's left, right? So he's going to start from here, and he's going to go left. And then how left does he go is the real question. So it says over here, he goes left less than x1. If the crocodile points that, okay, yeah, I need to shut up. But basically, x1 is greater than x2, which means he goes less than that amount of distance, okay? So let's just say he goes this much. All right, he goes that much. Just kidding, right? Yeah. Because also we need to look at this, right? What does this mean? It means if this is 0.5 of x1, that means he goes more than 0.5, which means he goes more than this much. So I'm right. I am right. Which means this is how much he goes for x2. And now it's asking for x2, x1, and x total. So now it's asking you for the relation between x total and x1. So what is displacement? Displacement is equal to initial. So like if you run in a circle, the displacement is 0, right, guys? So the displacement is actually the distance from this start guy, to x2. It's not from here and then to there. All right, do we get it? Like, I hope I'm making sense here. It's not the distance from to and back. It's just from the start and the end is right here. And look at that. It's like such a small distance from the start to the end. So just using our basic freaking eye skills, right, we can see that x1 is by far the biggest. It has this much room, or this much space walked, right? And then x2 is a tiny bit smaller. It's from here to here, right? It's from here to here. So that one's a little bit smaller, so I'm going to put x2 in the back because x1 is bigger than x2. And then we have x3, I'm going to call it x total, which is literally what the question's asking for. It's the displacement from the start and the end, x total. And that is, as you can see, is a very, very small. I'm literally going to move the little boy up there so you can see. It's such a small distance. So so that means x total is less than that, okay? Easy. I hope the illustrations were helpful, but yeah, that's the answer. All right, boys. Next question. I'm literally just gonna freeball this question because I know I said they don't give us a lot of variables, but this one is, which means
You're never seeing a question like this on the A/B test. I promise you.
This is unbelievably easy. So it's asking for acceleration, which is just equal to change in velocity over change in time. It's asking for cart A and cart B. So what is cart A? The cart A has a change in velocity of, if you don't know this, you're cooked, it's 3 meters. So that equals to 3 meters in a time of 3 seconds. Yeah, there's no way they're giving you a question like this on the AP test. Or on the national exam. That's how Heimler would say it. But anyway, cart B, 4. So 4 over 2. Yeah. What's the ratio of 1 to 2? 1 to 2. Hello? Next question.
so now it's asking for an object moving horizontal surface. So it's like this. Okay, why am I even doing this, bro? Like, it's just asking for what gives us the acceleration. So what is acceleration again? V over t. Number 1, it gives us v and t. So this one looks promising. But then it's asking for instantaneous. So if you take the entire freaking graph, it's just going to give the average, not the instantaneous, right? So this one, wrong. B, it's going to take the time from 5.1 and 4.9, which is correct because A, it's giving you the velocity and the time, and it's also the one that's like right next to the time it's asking for. So this one's right, but let me explain why the other ones are wrong and how you can instantly just eliminate them. So this one's wrong and these two are wrong. It's calculated with change in velocity, not average velocity. Are you good? Next question. Car on the road. Okay, I'm gonna give you guys some time to read this so I can read this myself.
Okay, so it's literally just asking for average velocity. What is average velocity? I'm going to just write it all the way at the top. It's change in displacement over change in time. So anyway, so it's asking for between t0 and t5. So at t0, x is equal to 0. So let me just write that down. And then when t equals 5, x equals 40. Dude, it would never be this easy, I promise you. And now it's asking for average velocity between t5 and t10. And I'm going to do this in a different color. From at t5, we already know x is equal to 40. Oops, denominator. And now at t equals 10, x is equal to 80. So now it's asking for the average velocity. What is average velocity? You already know it's d over t. So the change in displacement for this one is going to be, I'm going to write in, it's 40 over 5, which equals 8. So that's the first one. This one is 80 minus 40 over 5, which is just 40 over 5. 40 over 5 is equal to 8. They're the same. So, it's this one, because it says same distance. Okay.
All right, next question. Question 7. Balls. Okay, whatever. Okay, basically it's just asking you for instantaneous speed of the ball immediately before it reaches the ground. Just completely cross that out. Basically what it means, it just means VF. And what is the correct expression for VF? Is VF equal to GT?
I've never seen that in my life.
Okay. So what is the formula for VF? Well, if you use the first kinematic equation, VF equals VI plus 1/2 A. Yo, what am I doing? Yo, it's VF equals VI plus AD. Alright, now which of these is that? Is it GT? No. Is it H over time? No. I think I see it. It's this. And is it 0? No. Alright, are we good? And the reason why, oh my gosh, it's G and not A, it's because it's gravity, because it's vertically. V acceleration in the y direction is always equal to gravity. Okay. Next question. All right, for this next question, it's asking which of these could theoretically be a height that the ball goes through and the velocity that goes along with it. So I'm going to draw it so you guys understand, because I know I just said like a bunch of gibberish, right? So you're up 2 meters in the sky. 2 meters, and then you throw a ball and it goes like this. So what it's basically asking you is which of these is correct. Okay, that's kind of obvious, but anyway. So the first thing we need to know is it's giving you a bunch of like AP lingo. What we really need to realize is that before it hits the ground, velocity What does that sound like? It sounds like final velocity. So we're going to write v final for that. And then what else are we given? Our givens are really important. So the height being 2 meters, that's pretty important. Ooh, initial velocity being 15 meters per second. What else? Oh, it's thrown vertically, which means if it's only thrown vertically and not horizontally, that means horizontal velocity is equal to 0. And then acceleration in the vertical direction is always equal to gravity, which is, let's just say 10. Or is it 10? It's actually going to be negative 10 because if you're throwing it up, the gravity is going to oppose it, so it's going to be in the negative direction. Am I making sense here, boys? Anyway, so what kinematic equation can we use to, solve this? Because it's low-key kind of confusing. I kind of got this wrong the first time. Is it the first one? VF equals VI plus AT. Do we have time? No, we don't. So that's can't be that one. Is it D equals V initial T plus 1 half AT squared? No, because we also don't have time. So we need to use the only one that doesn't require time, which is VF squared equals VI squared plus 2 AT. Okay, so we're going to start plug and chugging. There is also a way easier way to find it out, but we'll save that for later. First one, I'm going to write this in blue so you know that I've locked in. 225 is equal to initial velocity, which is 225, plus 2, negative 10, negative 2. What is this? 20, 40, 265 is equal to 225. That's wrong. So it can't be A. Next, we're going to be doing B. Final velocity is 5. 25 is equal to the initial squared, which is 225 plus 2, negative 10, 0.5. That is crazy. Wait, that could low-key be right. Negative 20, negative 10. No, never mind. What am I saying? So these cancel out. 215. Yeah, that's not right. So it can't be B either. And now let's try C. C. Final velocity is 324, right? 8 times 8, yeah. Equals 225 plus negative 10. Oops, I meant to put 2 there first. And then D is difference between 2 and 10, which is 10. That's negative 100 times 2, which is negative 200. 225 minus 200. Is that equal to 324? No. So this one's wrong, which means by process of elimination it has to be D. And let's just confirm that it is D. Let's see. VF is going to be 25 equals 225 plus 2 negative 10. 10. Is this correct? 200 negative 200, 225 equals 25. 25 equals 25. Oh. Anyway, earlier I mentioned that there is an easier way. What is the easier way? Well, it's low-key by using common sense. And I know some of you guys like using equations. So this might not be the move for you. But anyway, let's go back to this drawing we have right here. So at 0, it's going to be over here. Okay? Could it be at 15 meters per second? Negative 15 meters per second? It could be. It could be. Because as we know, gravity opposes the initial velocity. So what I'm thinking, this is actually what I put initially. And I freaking got it wrong. So what I was thinking was 15, and then gravity opposes it, 10, and then as we know at the vertex, it's always going to be 0, and then negative 10, then negative 15, then negative 20, but I was kind of slow, so I didn't realize that it's never going to be, it's always going to stay the same, you know what I mean? So this always has to be lower than the initial velocity if it's going down. But the reason why these other ones are wrong, B and then C, the reason why they're wrong is B, it goes up. Okay, B could theoretically be right, but I'm too bored. I don't know. I can't. I don't really want to explain this, but the reason why C is undoubtedly wrong is because, like I said, gravity always opposes it. So if it starts off at 15 and then you move up 2 meters, gravity is gonna move downwards on it. So it's gonna be less than 15. It's not gonna be more than 15. So it cannot be 18. In no world is it gonna be 18. It's always going to be like maybe let's just say 12 or maybe like 10. Okay, so that's why D is right. Okay. All right, for this next question number 9.
Yeah, you guys are getting the sped up treatment. I don't care. This one is like
Unbelievably easy.
so. Basically, it's asking for T1. T1. It's asking for the type of motion. So let me just brush over the two types of motion. There's constant and then there's like acceleration. Okay, this basically means the velocity is constant. This means the velocity is not constant. If it's not constant, that means there's change in velocity, which means there's acceleration. Am I clear? So basically over here, there's obviously acceleration, which means A is wrong because it can't be moving at a constant speed. It also means B is wrong because it's not moving at a constant speed. It also means C could be right and D could be right. So now we need to find T2. Is T2 constant or is it accelerating? Well, this looks like a straight freaking line, so that means it has to be constant, which means it's C and not D. Are we clear?
Yeah, you're not seeing this on the AP exam.
Question number 10. Okay, I'm gonna keep it a buck. Yeah, I got this one wrong. But basically what College Board wants you to do is you need to realize that the displacement equals the area under the VT graph, okay? So let's just do that. So this one is 1, 2. This one is that's 0.5 high, and then 2. So it's, let me just write down the formula. It's 1/2 BH. If you don't know this, you're cooked for the exam. If the B is 0.5, the height is 2, that's the answer is 0.5. And then for the other side, it is going to be 1, 2 plus BH of 2 and then 3, which is just 3. Sorry, I forgot to write. And then on this side, it's going to be 1, 2 plus 3 because 1/2 BH, it's 3 times 2 times 1/2. These two cancel out. 3 plus 2 is 5. What's the ratio between 2.5 and 5? 1 to 2, because if you don't know that, you might be cooked, buddy. Next question. Okay, this is the type of stuff you see on the exam. Some stupid stuff like this. But anyway, you guys can read it. I'm going to try to figure out how I'm going to answer this. I mean, I know the answer, but like, how am I going to sway it? Or like a student, like...
Shock polite can understand it, you know?
Like some idiot like that, you know? Anyway. Okay, so as we can see, it's basically talking about a car. I don't care about these coins, you know? So basically what it's talking about is the car is initially moving. It's at rest. Then it goes this much distance. And it says every second. And then now it starts moving this much distance 1 second. And this much. And then this much. So it accelerates. And then it starts decelerating. Okay. As you can see, the middle is huge. It's fat, bro. So we know it is not constant. Because if the acceleration was constant, each one of these blocks would be the same. So immediately eliminate this one. Eliminate this one. So it's either A or B. Acceleration is not constant because the spacings between the two coins are not all the same. How could this... This is what I put. I put B and I got it wrong. But let me try to explain why. Well, it could just have the same acceleration, you know? Let's say A is equal to 10 meters per second squared. It means... Let me just try to draw it out for you small brains like me, because I got this one wrong. 10 meters per second means it's going to start here. It's going to go like this, then like this, then like this, then like this. The acceleration stays the same the entire time, but the spacings are freaking not the same. But it still has the same acceleration, which means that's wrong. So that means it must be A, okay? Because it increases and then it decreases, which means the acceleration went from like 10 meters per second over here. Let me just make it different for you like small brains. Sorry, okay. I'm with you guys, because that was me. And then over here, it decelerates. So it goes to like -3 meters per second squared. Am I clear? So, I know B looks tempting, but that's literally... Let me just try to re-emphasize my point. Let's say you have a ball, right? You drop it right here. After 1 second, it's going to be here. 2 seconds, it's going to be here. 3 seconds, it's going to be here. You see how these distances are not the same? That doesn't mean the acceleration changes. It just means that right? The acceleration remains the same. All right. If I can understand that, I hope you guys can understand that. Well, yeah. Are we clear? It's A. Next question. This might be like one of my least favorite questions of all time. But, all right, I'll give you guys 30 seconds to try to figure it out. And then we can chill from there. I actually kind of need to read this. It's asking for time. Okay. So, this is kinematics we're talking about. What's one of the kinematic thingies that involved distance or displacement and time? The second one, d equals the initial t plus 1/2 at squared. So, you know that the distance remains constant. So the first time, what happens? The first time, I'm going to do it light blue. Okay. The air is not moving relative to the ground. So basically, there's no wind. Okay. And it takes the boy V A times Tm. On Tuesday, there's a wind that moves with constant speed VW. So on the second day, they covered the same displacement in VA plus VW T. Okay, so how can we relate these two? Simple. So we just need to equate these guys to each other. So we're gonna do VA TM is equal to VA plus VW TT. So now we just need to it wants you to put it in forms of TT. So then we're just going to divide both sides by VA plus VW. So the answer is going to be TT is equal to VA TM over VA plus VW. And if you're wondering why you can't cross out these ones, you might be cooked for the exam. But basically, if it's connected by a plus sign, nothing can be in you can't change it. Basically, like you can't just do it. You can't cancel it out. Sorry. Yeah, you got to call up Ackerson for that one. But nothing you can do can break that plus sign right there. So what answer choice fits with this? I think it is this one. Yeah. Yep. All right, so for this next question, it's asking about relative speed. And this one's low-key kind of... It's light, but it's confusing at the same time. So lock in your answer. Click that follow button when you have it locked in. And make sure to share copy link when you're done. All right, but anyway, basically relative B to A just means like if you're in car A, how much faster or how much slower is car B going? Like, am I making sense here? It's the difference between their velocities with respect to car A. Respectfully. So if car A is 10 and this guy's 30, the difference is going to be 20 meters per second. My bad, negative 20 meters per second. Am I making sense here? Low-key, no, but like, I hope you understand, because 10 minus 30 equals negative 20 meters per second. Okay. Yep. Next question. I need to zoom out. Sorry, guys. I wasn't zoomed out. I'm going to put my guy right here. That's where my... So anyway, I'm going to let you guys read it for 30 seconds. I'm going to try to explain it in the best way I can. But just imagine this. you're on a train. Let's have like little cars. This is Mayank Tyagi. This is
His subordinate, Roshan Ramesh.
he rolls the dice, the blue dice, and the train's going this way, right? So first in the positive x direction, in the negative x direction. So when Roshan rolls it this way, obviously the speed. Let's say he rolls it at 5 meters per second. Since they're going the opposite direction of the train, it's probably going to be like 4 meters. It's going to be a little less. I'm just going to say 4 meters per second because, sue me or whatever. And then another guy, Mayank, little m right here. He stops it and he rolls it back with the same speed of 5 meters per second. Sorry if I'm circling so much stuff. But anyway, he rolls it back with 5 meters per second. And this time, since they're going in the same direction of the train, it's going to go a little faster. It's going to be 6 meters per second. Okay? So now, which graph properly demonstrates that? Is it... So first of all, the 0 is here. I hope if you don't know that, you're cooked. So initially, they go from 4. Let me just write it in big red. They go from 4 meters per second, Roshan. And then 6 meters per second, Mayank. So, is anything here negative? Nothing here is negative, and this is very clearly negative, so it can't be this one. It goes from 4 meters per second to 6 meters per second, which means it can't be this one, because this is higher. This would be the 6, and that would be 4. That one's wrong. Is it this one? No, because it never hits 0. Does it hit 0? Okay, wait. I'm slow. The reason it's not this one is because the velocity is not slowing down. Like, it's not like... It says constant speed, right? So, it's not slowing down. Right? So, out of here, it has to be this one. Do you get it? The 4 meters per second of Roshan and the 6 meters per second of Mayank. Next question. So, this one, if you look at it and you think you're cooked, you're not cooked. You're not cooked because you got me right here. So let's just lock in on this one, and then yeah. I remember the start of the year. She always made us do some stupid like chart where it was like, all right, skip this part if you don't want to hear me out. But like, what was it called? It was called the I guess. I guess. Oh my gosh. All right, we're gonna pull out an I guess right here. All right, so I guess stands for given. You know what? We're doing illustration. Okay, we have an illustration. That's done. We need to... What are we given, guys? Guys, what are we given? What are we given, guys? We're given these... Oh, this is exactly what you're gonna see on the AP exam. There's no numbers or anything. All constants. Yeah, you guys are cooked for the AP exam. No, we collectively are cooked for the AP exam, but... Anyway, it's all constants, which means V0. Guys, what would I say about sine? Sine is... Wait, am I slow? No, sine is vertical. And then cosine is horizontal, so we know that Vx equals cosine V0. And then Vy equals sine theta. Oops. Theta. Silly me. Anyway, what else? We know that Vx, oops, I meant Ay equals 9.8, Ax equals 0 because there's no acceleration. There's never acceleration in horizontally. What else? The instant it reaches its highest point. So what does that mean? That means Vf is 0. Yf is equal to 0. The ball rebounds from the wall with the same speed and then lands at the same point, which means that... Okay, well, yeah, okay. So basically, horizontal distance, how do we find that? We need the time. So let's just start off with whichever one we have more of. So I think we have a lot more y's here, so... Let's just work on that. So we need to find the t. T is like... Oh, I guess. My bad, guys. My bad. Let me just change this to IGW. What do we want? We need the t, buddy. And we need the dx. We low-key don't need the dy, so I'm gonna just write it anyway. Actually, no, we literally don't. We just need the time and the dx, okay? And then you guys, you go away. Screw I guess. It's IGW now. Okay. Anyway, so first we need to find the t, so we're gonna use y. So we know that vf equals vi plus at. I might be using the wrong formula. 0 equals v0. No, I'm right. Cosine. No, I'm wrong. I'm wrong. MB, guys. This should be sine theta plus 9.8 t. So t is equal to v0 sine. Am I slow? No, I'm right. I'm gonna just write g, because as you can see, not a single. All of them use g. Okay. Now that we have t, you see how it's like not like a number, but it's like some stupid like constant thing. Yeah, you guys need to do that on the AP exam. Those you're cooked. Anyway, now that we have t, now we can just use the displacement formula of, guys, what's the displacement formula? What's the second kinematic equation? It's going to be d equals vit plus 1/2 at squared. So now we just plug in it's the same speed at which when it struck the wall, right? So the same speed means that it's still cosine v0, which means it's cosine theta times v. Maybe I should put v initial in the first, but whatever, guys. Times time v0 sine over g plus. And guys, what is acceleration? It's gonna be 9 point. No! That was a trick question. Acceleration is always 0. Aha. So anyway, that's our answer, guys. It's gonna be v initial squared times sine theta cosine theta over g. That might be one of the most satisfying equations to ever grace my mind or grace my hand. Anyway, which one's the answer? It's this one. Sneaky 2g. It's wrong. Next question, boys.
You guys get 5 seconds to do this one. 5, 4, 3, 2, 1. Okay, anyway. So basically it's asking for immediately before the ball returns to the ground. Guys, if there's anything you should learn today, it means that what that translates to is VF. So we're just going to delete that and we're just going to write what is the VF, buddy. So if it's kicked at an angle, it basically means that it's kicked like this with the theta. This one is V0 cosine theta. This one is, sorry guys, this one is V0 sine theta. And then, I hope I'm recording this. I am. Okay, anyway. 30, oh, I literally know the angle. It's sine 30. Sorry guys. It's the eyes. 30 degrees. Initial speed. So it's asking for the horizontal component. Oh my goodness, I'm literally giving it to you. So initial is 12. I hope you guys know where that came from. Now you multiply that by cosine 30. What's cosine 30, guys? Root 3 over 2. There's some Indian guy who taught me that. Like on TikTok, there was like yeah. So 12 times root 3 over 2. That's 6 times root 3. Root 3. I low-key don't know what it is, but let's just use guesstimation. Can't be this one. Can't be 6. Can't be lower than 6. Has to be 10. See what I did there? No calculator needed. Are we good? Next question.
All right, for these last two questions, this one really isn't that hard. If you think about it, it is kind of confusing, but just go ahead and try to solve it. Okay, anyway, so basically it's asking for reaches the speed, ground speed with its speed v. Dude, this is literally just asking for final velocity. How do we find final velocity? Well, there's two equations. We can use VF equals VI plus AT. VF squared equals VI squared plus 2AD. Okay, now, do we have acceleration? Yes, for this one, it's 9.8. Yes, we do. Do we have time? No, but I'm sure we can derive it, so I'm just going to put a dot. But do we have VI? No, we do not have VI for any of this. I mean, of course, we know VI for this one is 0. VYI equals. But for this one, we don't know it. So, we literally cannot determine it. Okay. We do not know the initial speed. So, It also says some stuff about the heights, but I'm gonna keep it a buck. I don't know how that relates. I mean, I'm probably stupid, but like it's late, bro. I don't know. But just know that if you aren't given the initial speed, like how can you determine the velocity? You know, let's say they shoot 1,000 miles an hour. Obviously, it's gonna be faster, but they don't tell you that. So, enough yap. Next question. That one's it's respectable if we get that one wrong. But anyway, this one, oh my favorite X and Y components. I was literally yapping about this yesterday. But anyway, if you watch my part 1 video. But anyway, it's asking, how does the horizontal component change? So basically, let's say you release at 5 meters per second. When you release it 90 degrees up, it's going to be cosine 90 degrees. And then when you release it 0 degrees, it's going to be cosine 0 degrees. So cosine, what does it start off with? It starts off at 1 and then it goes to 0, right? Right? So it decreases, right? Because cosine 90 equals 1. Cosine 0 is equal to 0. So it decreases because 5 times 1 is 5, and then it goes to 0. Okay? 5 to 0 decreases.
So now we have to do it. Is it constant or is it increasing magnitude? Well, since I'm kind of slow, I just checked it. I saw, sorry guys, I need to grab my calculator. This is 2 times this. Oh. Alright, anyway. So what I did was I checked if cosine was constant, and the way I did that was I found cosine. So what am I doing, bro? I tried to find cosine 45, cosine 46, and then cosine 44. And long story short, all you need to know is that this one is equal to 0.69. This one is equal to, my bad, 4. What's cosine 45? I'm still for not knowing this. And then cosine 44 is equal to. So what you need to know is that the difference between these two are not constant and they're always changing. Like, cosine 44 and cosine 45 are not like 0.1 apart. No, they change. Anyway, so it's increasing magnitude. Boom, it's not a constant rate. Get out of here. And now we're done. We are freaking done with AP Physics Kinematics. So, hope you guys enjoyed. It's a long night for me. More videos coming out soon. Fun fact, I actually know the AP Physics teacher. Like, I got in contact with her, Miss Nikolaiva. So, stay tuned for the collab, Miss Nikolaiva x Michael Pang. Make sure you stay subscribed, ring the bell, so you never miss out on my future uploads. We're going to do FRQs. Yo, I hate doing FRQs. I'm going to be honest. We're only doing MCQs on this channel. Unless I'm having a really good day and I want to do FRQs. Or if you guys petition in the comments and you say you want to do FRQs. So we're going to do MCQs, all the AP classroom MCQs, progress checks. We're going to do MIT next week. We're going to do some Nikolaiva stuff, review. I got her email. Because I'm just that guy. Anyway, see you guys tomorrow. I'm going to dip. Bye.